In a world filled with questions, where wisdom knows no boundaries, join us on a journey of enlightenment and endless learning. Eternal Teachings. TV. Discover the eternal.
The concept of time travel, a staple of science fiction, has intrigued humanity for centuries. The idea of traversing the fourth dimension, journeying to the past or future, and potentially altering the course of events has captured imaginations worldwide. While time travel remains a theoretical concept, the underpinnings of its possibility are rooted in scientific principles, particularly Einstein's theories of relativity. In this comprehensive exploration, we delve into the science behind time travel, examining the theoretical frameworks, potential mechanisms, and the challenges and paradoxes that arise from manipulating time. To comprehend the possibility of time travel, it's crucial to understand time as a dimension, akin to the three spatial dimensions of length, width, and height. In Einstein's theory of special relativity, time is interwoven with space to form a four-dimensional fabric known as space-time. This fabric can be warped and distorted by mass and energy, leading to the phenomenon of time dilation, where time passes differently for observers in relative motion or in different gravitational fields. Time dilation, a consequence of special relativity, is the phenomenon where time passes more slowly for an object in motion relative to a stationary observer. This effect becomes more pronounced as the object approaches the speed of light. The classic illustration of time dilation is the twin paradox, a thought experiment where one identical twin remains on Earth while the other embarks on a high-speed space journey. Upon returning, the traveling twin would be younger than the Earthbound twin due to the time dilation experienced during the journey. Einstein's theory of general relativity expands on the concept of time dilation by incorporating the effects of gravity. According to general relativity, the presence of mass or energy curves space-time, and the stronger the gravitational field, the more time slows down. This means that time passes more slowly near massive objects like planets and stars compared to regions with weaker gravitational fields. This effect, known as gravitational time dilation, has been experimentally verified and is taken into account in the operation of GPS systems. One of the most popular theoretical mechanisms for time travel is the concept of wormholes. Wormholes are hypothetical tunnels that connect two distant points in space-time, potentially allowing for shortcuts through space and time. If traversable wormholes exist, they could theoretically enable time travel by providing a pathway to the past or future. However, the existence of wormholes remains purely theoretical, and even if they do exist, their stability and traversability are uncertain. Another theoretical approach to time travel involves cosmic strings, hypothetical one-dimensional defects in space-time that are believed to have formed during the early universe. Some physicists speculate that manipulating cosmic strings could create closed time-like curves, pathways in space-time that loop back on themselves, potentially allowing for time travel. A similar concept is the Tipler cylinder, a hypothetical massive rotating cylinder that, if constructed with sufficient density and rotation, could theoretically warp space-time to create closed time-like curves. The concept of time travel raises several paradoxes, the most famous being the grandfather paradox. This paradox asks what would happen if a time traveler were to go back in time and kill their own grandfather before their parent was conceived. If successful, the time traveler would never have been born, creating a logical contradiction. Several solutions to the grandfather paradox have been proposed, including the Novikov self-consistency principle, which suggests that the laws of physics would prevent any action that would create a paradox. Another approach to resolving time travel paradoxes is the many worlds interpretation of quantum mechanics. According to this interpretation, every quantum event creates multiple branching universes, each with a different outcome. In this scenario, time travel would not involve changing the past in one's own universe, but rather branching off into a parallel universe where the past is different. This interpretation eliminates paradoxes by allowing for multiple timelines and outcomes. Closed time-like curves, the theoretical pathways in space-time that enable time travel, raise concerns about causality and the potential for altering the past. Some physicists, notably Stephen Hawking, have proposed the chronology protection conjecture, which suggests that the laws of physics may ultimately prevent the creation of closed time-like curves, thus protecting the integrity of causality. Time travel to the future is a well-established phenomenon within the framework of special relativity. As mentioned earlier, time dilation allows for time travel to the future by simply traveling at high speeds or experiencing strong gravitational fields. Astronauts on the International Space Station, for example, age slightly slower than people on Earth due to the effects of time dilation. The possibility of time travel raises profound ethical and philosophical questions. If time travel were possible, it could potentially be used for nefarious purposes, such as altering historical events or interfering with the natural course of events. The potential for unintended consequences and the erosion of free will are also significant concerns. The ethical implications of time travel would need to be carefully considered and regulated if it were ever to become a reality. In conclusion, while time travel remains a theoretical concept, the science behind its possibility is rooted in well-established principles of physics, particularly Einstein's theories of relativity. Time dilation, wormholes, cosmic strings, and other theoretical mechanisms offer potential pathways for traversing the fourth dimension. However, the challenges and paradoxes associated with time travel, particularly the potential for altering the past and creating logical contradictions, remain significant obstacles. The ethical and philosophical implications of time travel are also profound and would need to be carefully considered if it were ever to become a reality. As our understanding of the universe and the laws of physics continues to evolve, the possibility of time travel may one day move from the realm of science fiction to the realm of scientific reality.